questions 21 through 25 on the 2012 Grade 10 Cayley Math Contest. If x and y are positive integers with x greater than y and x plus xy is 391, what is the value of x plus y? X plus xy is equal to 391. So where do you go from here? Well, you have to break up 391 into its prime factors, and those are 23 and 17. So this side, we can factor it 1 plus y. So since x is greater than y, that means x is my 23, and my 1 plus y is my 17. So x is 23, and 1 plus y is equal to 17. So solving for y, I get y is equal to 16. They want me to find x plus y. So x plus y is going to be 23 plus 16, and that is 39. So number 21, the answer is B. Five monkeys are seated around a table. Their seats are labeled PQRST in clockwise order, as shown. The 5 monkeys are randomly numbered, monkey 1, 2, 3, 4, and 5. Monkey 1 remains in its seat. The remaining 4 monkeys then sit themselves in the remaining seats so that they are seated in clockwise order as monkey 1, 2, 3, 4, and 5. What is the probability that the monkey originally in seat R moves to seat P? We have a few scenarios here, and each scenario I will discuss, and then we'll try to figure out the probability for each. So first, let's label all of these according to the way they've labeled it, PQRST. Now let's talk about monkey number 1. If monkey number 1 is at position R, right here, then because he remains in his seat, nobody is actually moving to seat number P. Because normally there has to be a rearrangement. And he's going to stay there, so the guy in seat R doesn't move. So nobody's going to P. Maybe some other monkey is, but he's not. The question says that the monkey in seat R has to move to seat P. If M1 is in seat R, he will not move to seat P because he remains in his seat. So if this is a scenario where M1 is originally sitting in seat R, the probability is 0 because he's going to remain in seat R. Similarly, the next scenario is if monkey 1 is sitting in P. He remains in his seat. So whoever's in R, if they move around, that's fine, but they're never going to be able to move to P because P is occupied by M. So in this scenario, the probability of somebody moving from R to P is also 0. Nobody can move into seat P because monkey 1 is in that seat and he remains there. So the only way we're going to be able to extract a probability in this question is if monkey 1 is either here originally, seat Q, or seat S, or seat T. So we'll talk about each of these one by one. If monkey 1 is in seat Q, we want the guy who's here to move to here. Okay, so we got to do a little bit of thinking here. Who's going to go to P if it's going to be arranged in clockwise order as 1, 2, 3, 4, 5? Well, 1, 2, 3, 4, 5. Well, it's got to be monkey 5. Once the clockwise order happens, monkey 5 is going to end up in P. So that means he must originate at R in order for this sentence to be satisfied. The monkey originally in seat R moves to seat P. He was sitting in seat R, but then after the rearrangement happens, he moves to seat P. That is one scenario. So what is the probability of this? Okay, first we have to look at the probability that M1 is in Q. There's 5 seats we have to put him in one of those 5 seats. So the probability of that happening is 1 over 5. That's the probability of monkey 1 to be placed in seat Q. Then, in addition to that, monkey 5 has to have been placed in R. But be careful, this is fixed. So now monkey 5 has to choose between these 4 seats. And the probability of therefore putting monkey 5 in one of those 4 seats is 1 over 4. So that probability is 1 over 20. Okay? So a little tricky, not super tricky, but a little tricky in my opinion. Not the hardest, but definitely not the easiest. Somewhere in the middle. Okay, so we've done with this one. This circle is done, this circle is done, this circle is done. Those were zeros, so they don't contribute anything to our probability. Now let's go to the next scenario. The good news, you probably already figured this out, is that the next scenario is identical. We want monkey 1 to be in S, right? So there's 5 choices for the seat for monkey 1, and of those we want S, so that's 1 over 5. The probability of putting monkey 1 in seat S. Then, now we have to think about this. We want some guy to go from R to P. Well, when the arrangement happens, it's got to be monkey 2, monkey 3, monkey 4, monkey 5, like that, right? So monkey 3 has to end up in P. So that means he originates in R. See, he originates in R, but then once the rearrangement happens, because it's done according to clockwise order, 1, 2, 3, 4, 5, he's going to end up going to P. So what's the probability of that happening? Well, it really just means what's the probability of having monkey 3 originally sit in R? Well, since S is already taken, he's got 4 possible choices, and of those 4 possible choices, he has to choose 1. So the probability of putting monkey 3 in one of those 4, which is R, is 1 over 4. And that again is 1 over 20. And then finally, we've got the last scenario. Monkey 1 is now fixed at T, but we want the guy who's originally there to eventually end up here. Well, when you do the rearrangement, it's going to be monkey 1 there, and then 2, 3, 4, 5. So monkey 2 is going to end up in P, so he must have to originate at R. He's sitting there, but then after the rearrangement happens, he ends up going to P. So in the same way, what's the probability of choosing seat T for monkey 1? Well, 1 out of 5. And then what's the probability of choosing seat R for monkey 2? Well, he had only 4 choices, so it was 1 out of 4. And that again is 1 over 20. So to get the total probability, we have to add up all the probabilities. 0, 0, 1 over 20, 1 over 20, and 1 over 20. And when you add up those probabilities, you get a grand total of 3 over 20. And therefore, number 22, the answer is C. In the diagram, P, Q, and R lie on a circle with center O and radius 12. The point S lies on OR. If POR is 135 degrees, the area of the trapezoid OPQS is closest to. Well, let's cut up this diagram a little bit. I'm going to draw a line like that, that's perpendicular, and then a line like that, that's diagonal, so this is perpendicular. All right, so the good news is that when you do that, you are able to cut this into 3 equal triangles. All of these are equal. And you say, well, how do you know that? How do you know for sure that they're equal? Well, that's where the angles come into play, right? And also the sides, not just the angles. So, for example, this was 135 degrees, and if I made this into a right angle, which I did, that means this angle in here is 45. It's 135 minus 90. So this was a right angle, that's 90, so therefore this is 45. So that means this side and this side are the same. And then this side right here is the radius of the circle, which they told me is 12. And in a very similar way, you can do that for all the other triangles. For example, this is also the radius because O is the center, and then Q is on the circle. So that OQ is a radius, so I can label that 12. And in a very similar way, since that's just a diagonal, this is going to be 45 degrees, that angle in there. And then since this is 90, this is 45 degrees right here. And then the identical kind of story holds true for that triangle. 45, 45, and 90. So this is again isosceles, so that is equal to that in terms of the length. All right? So since this side is the same as that side, all of those sides that I have drawn this symbol are all equal. Okay? So I hope that makes perfect sense. And we also know that this side is parallel to that since we have right angles here. So all we really have to do is find the area of one of these triangles and then multiply it by 3, and we've got the area of OPQS. So OPQS will basically just be 3 times the area of one of those triangles. So I'll just write a triangle right there. Okay, so how do we figure out the area of the triangle? Well, I will label this side x, and this side, of course, therefore is x also, since it is equal. And then just use Pythagoras on that triangle to figure out x. So we have x squared plus x squared is equal to 12 squared. So 2x squared is equal to 144. X squared is equal to 72, and therefore x is equal to the root of 72. So 3 times the triangle, well, one triangle is 1/2 base times height. The base is x, the height is x. So this is 3 over 2 x squared. Well, x squared I just got was 72. So it's 3 over 2 times 72, and that is 108. Yeah. So number 23, the answer is C. Six friends will exchange books in their book club. Each friend has one book to give to a friend and will receive one book from a different friend. No two friends trade books with each other. In how many ways can the books be arranged? The challenging aspect of this question is that there's 2 scenarios. If there was only one scenario, I think it would be a little bit easier. But unfortunately, there's 2 scenarios. So I've got 6 friends, so I'm going to label them A, B, C, D, E, F, A, B, C, D, E, F. And since there's 2 scenarios, I've got to explain this in 2 different ways. So 2 circles. Okay. So let's start with, I don't know which one is easier. It doesn't really matter, but let's just start with this one here, the one on the right. Now, in that circle, I have to somehow satisfy the conditions of the question. So let's start off. A is going to give a book to B. Okay? But then A has to receive a book from somebody, but he cannot receive it from B because no 2 friends trade books with each other. Right? So, okay, let's just keep going. B gives a book to C. C gives a book to D. Okay, you get the point here, I hope. D gives a book to E. E gives a book to F. And then finally, F gives a book back to A. This is a legitimate scenario where it's all just kind of going round and round. That's just one, though. One of many. As you can see, there's answer choices are pretty large. This is just one. So, for example, if the answer was 200, this is just one of 200 scenarios. We have to figure out how many. So how do we do that? Obviously, we're not going to write out 200 or whatever the answer is. So then we look at this and say, okay, what are the possible choices? So, for example, if I started with A, I made a diagram that went to B. But what other points could A go to? Who could A give a book to? That's what that represents. Well, initially, he could give a book to either B, C, D, E, or F. So he's got 5. He's got 5 choices. So I put a 5 there. 5 representing the number of possible ways he could move forward with his book giving. Then you get to B. how many choices does B have? Well, in my diagram, I made B go to C, right? That's legitimate. But B can also give a book to D. I could have done it like that, right? He could also give a book to E. I could have drawn it like that. He could also give a book to F. I could have drawn it like that. But he cannot give a book to A. Why? Because no two friends can exchange books. Since he received a book from A, he cannot give a book back to A. So for B, it looks like there was only 4 choices. So I drew one, but there's 4 possible ways of B giving a book. So let's now go to C. C, I drew it in a way that he's giving a book to D, right? But he could also have given a book to E. I could have drawn it like that. Or he could have given a book to F. And he can give a book to F. But he cannot give a book to A in this scenario. Now you say, well, why not? Well, because remember, one of the ways of A giving a book was to C. I didn't draw it in, but that's one possibility. So if A gives a book to C, C cannot give a book to A. Does that make sense? So that means for C, it's just 3 possibilities. Now let's talk about D. We drew it, or I drew it, that D is giving a book to E, but D could also have given a book to F. And in a very similar way, that's the only possible choices for for D. And then for E, it looks like E can only give a book to F, and that's it. So there's 1, and then F by default has only 1 person to give a book to. So this is the total. So to figure out the total number, you have to multiply them, 5 times 4 times 3 times 2, and then times 1, but that doesn't affect the product. And this is 120. So from the first scenario, you get 120. So that takes care of case number 1. Now we turn our attention to case number 2. They say, well, how could case number 2 be different? Seems like case number 1 was pretty complete. Well, here's the story. It breaks up into 2 groups of friends. These 3 and these 3. They only exchange books within each other, and I'll show you how. A gives a book to B, right? Then B gives a book to C. And then C gives a book to A. And that is their scenario. Similarly, F gives a book to D. And then D gives a book to E. And then E gives a book to F. That is another scenario. Perfectly legitimate. Now we have to count up the number of cases. A is going to B. A is giving a book to B. That's how I've drawn it. But he could have also given a book to C. Or D, or E, or F. Now, I know that's a little confusing. You say, well, I thought you said they were separate. They are. But what I'm saying is that this B could have been any of these letters. I just grouped it like that. So A could have given a book to B, or could have given a book to C. But I could have also, instead of B, I could have put a D. You see what I'm saying? Right here, this is B, but it could have been a D. So that means that A could have given a book to D also. Or instead of putting D there, I could have put E there. Or instead of putting E there, I could have put an F there. So as you can see, any of the 5 could have started off that little chain. So that means this has 5 possible ways of being done. A to B or C, D, E, or F. Okay, I hope that makes sense. And then once you have B, B is going to give a book to C, right? So I've written like B to C. But instead of C, we could put here D, or we could put E, or we put F. So there's 4 possible choices for that letter. And therefore, this is 4. Now, once you have that, interestingly, now you've got 3 friends, and then C has no choice but to give a book to A. So that by default is just going to be 1 possible choice. And that's it. Once you've selected a group of 3 friends, they just kind of go around like that. In an identical way, this is 5, this is 4, and this is 1. So that's probably a slightly more difficult to come up with, but I sincerely hope that you understand that. So now we got to figure out the product. From here, it's 5 times 4 times 1. And then from here, we have another 5 times 4 times 1. So that means that's 20 plus 20, and that is 40. So we got 40 here, we got 120 here. So the grand total, if you add those two, is 160. So number 24, the answer is E. The digits of the positive integer n include no 9s, exactly 4 8s, exactly 3 7s, exactly 2 6s, and some other digits. If the sum of the digits of n is 104, and the sum of the digits of 2n is 100, then the number of times that the digit 5 occurs in n is. Well, n is some number. It's got 4 8s, 3 7s, 2 6s, and then a bunch of other digits. I have no idea what those digits are. But they tell me that the sum of the digits is 104. Well, so far, what is the sum of the digits? We got 4 8s, so that's 32. 3 7s, that's 21. We got 2 6s, so 6 plus 6 is 12. And then some other digits, and I'll just represent that as x, that the sum of those other digits. And they're saying all that equals 104. So that means if I do the math here, x has got to be 39. So that means these guys, whatever these numbers are, add up to 39. Okay, a lot of ways of doing that. So where do you even begin? Well, this is one of those questions. It's number 25. You're down to the wire. You got like 3 minutes. Now, how are you going to do this? Are you going to use a scientific method that takes 25 minutes, or are you going to use some brute force trial and error? I'm going to use the brute force trial and error. So here we go. I looked at the answer choices. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. Those are my possible. So I'm going to say, you know what? Let's start with a possibility. They want me to figure out how many 5s occur in this group. So let's go right down the middle and see if 2 works. So I've got 2 5s in here. 5, 5. That means the other numbers have to add up to 29, because 5 plus 5 is 10. So that means the other digits have to add up to 29. Okay, let's make a list. How can I do that? Well, I can put 4, 4, 4, lots of ways, right? 3, 3, 3, 3, 3, and a 2. This is going to be 29, right? This is 12, 15, that's 27, plus 2 is 29. Okay, and let's just say it's in order like this, that n is this number, exactly in that order. Okay, so n is basically this number right here, 888, and so on. And the sum of the digits is 104. Okay, I chose these digits to perfectly match up to 104. But now I'm interested in 2n. Okay, well, you obviously can't put this in a calculator, but you guys can do this, right? It's not hard. Multiplying by 2, 6, 6, 6, 6, 6, 8, 8, 8. Okay, but now you got a 5, so there's going to be a 0. So this is going to be 0, 1, 3, 3, 5, 5, 5, 7, 7, 7, 7, 7, and then a 1. So that is my wavy 2n. And the good news is that you can actually do this in a calculator. This part you can do on your own. You certainly don't need a calculator to multiply those numbers by 2. But if you're a bit confused about this section, you can put those in the calculator. Most calculators will go up to that many digits. Okay, so now I got to add up the sum of the digits of this guy. And when I do, I get 109. Okay, well, that was a bust, because 2n has to be 100. No problem. It's a lot quicker to do trial and error, in my opinion, on this question. So let's keep going. Now, you got some good luck or bad luck here. You can either go in this direction, or you can go in either this direction. I already tried 2 5s, and that didn't work. So I'm going to go in this direction. All right, so that means I'm going to choose an n that has 3 5s. Okay, so instead of 5, 5, I'm going to choose 5, 5, 5. That means the other numbers can be pretty much the same, like this. But I've got to make sure that one of the 3's becomes a 2, right? Because I went up, so I've got to go down to match it. Okay, so now I've got a different scenario here. This time I've got an n that's slightly different. And that sum is 104. Okay, now let's figure out my 2n. My 2n, like I said, initially it's pretty easy to figure out what is 2n. Not too hard to multiply those guys by 2. But then this guy, even if you don't want to do it, you can just put it in your calculator. Like if you didn't want to do it manually, you can just put it in your calculator, and that's the good part. So most calculators will go up to that many digits. So it's going to be 0, 1, 1, 3, 3, and then 5, 5, 5, and then 4 7s, and then a 1. Okay, so another wavy, I don't know why I keep writing it in a wavy way, but that doesn't matter. Now, what is the sum of the digits of this guy? The answer is 100. So you see how it worked out pretty quickly? And it makes perfect sense too. For number 25, which is, usually the hardest or one of the hardest questions, it works out. A lot of it is just trial and error. So the answer to this question is 3 5s, because they're asking how many 5s occur in the original n, the number of times that 5 occurs in n. Well, this is my n, and through trial and error, I found that if I put 5 3 times, it ends up to have a sum of 100 when I take 2n. So, in a non-scientific way, we found the answer to this question, which is 3 for number 25. Therefore, that is choice D.